Hey everybody, so sorry this is so dark. I'm trying to lighten it up somehow, but unfortunately it keeps just kind of staying dark on me, no matter how many lamps I move. And when I do that, I create shadows. So I'm trying not to do that, to create the shadow part because it's really even harder to see. We're going to be talking about how to identify similar triangles, especially when it comes to right triangles. It can be a little bit tricky. So we're going to use those triangles to solve for missing measurements. And I already pre-colored this so that you could see there's actually three triangles involved here. And what you need to consider is that you have a short side and a short side. These are what's going to go together. Even though CD is congruent to CD in this picture, as far as considering similar triangles go, these are not the same. So the short side goes with the short side. And here, this would be the short side as well. Short. So even though it's the hypotenuse of this blue one, it's still the shortest side of the, or the green, blue or orange one is still the shortest side of this blue one. Okay, so the shorts go with the shorts, the hypotenuses go with the hypotenuses, which kind of makes it handy and absolutely makes sense. So you have a hypotenuse, and a hypotenuse from here to here. Okay, those are all going to go together. And then obviously you have your long sides that will go together as well. So you have your long, and your long. Okay, when you're writing these, you're going to actually set up similarity statements, and it's going to help you figuring out like what you're doing and how you're solving things. And when I did this earlier too, I went ahead and set it up like this with little squiggles so you can see what goes with what. So you're going to use this information to set up proportions so that you can set them up and see if they're proportional. That's the whole purpose of this. So let's take a look at these triangles right here. Again, I told you that it goes with short side, short side, short side. So this one's kind of hard to tell. And you're like, okay, which one's the short side? Well, these are 90-90, right? And then you've got your hypotenuse. So when I did these, I actually went with the hypotenuse first because it was the easiest thing to identify. And then I threw in my other number. So right here, this is your hypotenuse of this triangle, this big triangle. So this is your hypotenuse. This is your hypotenuse of this triangle right here. And then this is your hypotenuse of this triangle right here. So if you throw it together like that, it makes it a little easier because you can say HI is going to be similar to JH. And then you just have to throw in your third letter. So HIJ is going to be similar to J. Well, I should have probably put HJ. That's all right. It's going to be similar to, there's a K here. Okay, so might have done that backwards. HIJ, and that's going to go to JHK. Nope, that's right. Okay, so when you're figuring out the similar triangles, that's one way to do it. So HJK is similar to IJK, and IJK is similar to IHJ. And it honestly does take a second to figure these out. I've already pre-done them, but it does take a second to figure these out just because they're like confusing to look at. If you need to pull them out into separate triangles to see what's what, do that. But it's not easy to look at sometimes. All right, so this next one, you got triangle MNO, the whole thing, and that's going to be similar to triangle POM. So POM. So you went from the right triangle to the N to the O, and then you went from the right triangle to the O to the M. Okay, I ended on the hypotenuse each time. So ended on the hypotenuse, ended on the hypotenuse. Okay, so then you also can say that MNO is going to be similar to PMN. And don't forget there's a right triangle here. And then POM is similar to PMN. Okay, cool. Now, that's all well and good, knowing how to set up similar triangles. But remember, that's what actually helps us when we are going to solve a problem. So, by the way, these directions are for the next page, and I'm not reprinting it just for that, because why waste the ink? Okay, so when you're figuring this out, first of all, start with a similarity statement. So in this one, it's going to be triangle EFG, similar to GFH. Okay, now I have certain measurements here that I can use. I know, for example, that EF, all of that is 5. So if EF is 5, I can write that down. It also is going to correspond with GF, and GF is 4. Okay, remember we're setting up proportions here. And then I have EG right here. I know that that is 3. And that's going to correspond to HG, which is my X. So then I can cross multiply and divide. I get 5x equals 12. So X is equal to 2.4. Okay? It makes sense that X is equal to 2.4 because this is one of those common triples. This has to be smaller, this side right here has to be smaller than its hypotenuse. And it has to be smaller than this hypotenuse too. So it has to be less than 3 and less than 4. Well, obviously less than 3. So it's actually 2.4. Okay, so it makes sense. The answer makes sense. All right. By the way, you can always pause the video if you need to kind of have more time to dwell over something. Probably fine. I'm not going to know the difference. Neither is anyone else. Okay, so this triangle LJM is similar to triangle MLK, and use what you got. So I have LJ right here, 13, right here. And that's going to correspond to ML, which is 5. So far I have 13 over 5. And then I have JM, so JM, and that's going to correspond with LK, which is not what I need. I need MK. So I actually want to use the one that goes with KM. So K, M, M, L. So KM is my X, and ML is the 5. Okay, so hopefully you can see how I just set that up. And I didn't confuse the poop out of you. So you get 13x equals 25 and x equals 1.92. That makes complete sense. And you're done. Okay, 3 more of these. So like I said, if you need something, pause the video and then take a look at the problem and see if you can figure out what I did or what I didn't do or what I need to do or anything. And if I make a mistake, please let me know, because you know I offer extra credit if I make a mistake and you can catch it right now. Not always, but right now I'll offer that because you're on your own over there. And that's not good because I definitely miss you. All right, so take a look at this one. Sorry, there's dogs out there barking because somebody's walking by. And I have my window cracked. So this right here, the whole thing is 9. And I'm looking at x over 6, right? The 2 legs of this triangle. So x over 6 is equal to short side 3 over x. Now you're like, wait a second. I got 2 x's here. And I'm like, yeah, I know you do. It's okay. It's okay to have a couple of x's because that just multiplies to equal x squared. And then you take the square root and you're good to go. Remember, when you have a square, you take the square root. Okay, 2 more. And then we'll call this video done. Find the value of the variable. So if I'm looking at this, I got this short side here, 6, over the short side here, 3. Okay, the short side of this triangle versus the short side of this triangle. So I'm talking about 2 different triangles, not the same one. Talking about the short side of this triangle, and then I'm talking about the short side of the other triangle. Okay, and then is equal to long side here, long side, plus 4. And that is going to be over 3 long, no, that's not the long side. I think it's over 6 again. Because you got the other triangle that you're worried about. So this is the long side of the small triangle and the short side of the small triangle. So this is 3a plus 4 equals 6 times 6, which is 36. Divide by the 3, and you get a plus 4 equals 12. Subtract the 4, a equals 8. I'm going to leave that there for just a second. I was dealing with 2 different things here, and it made it kind of confusing. Long side to the long side of this triangle. Okay, so that's the 2 I was comparing, a plus 4 over 6, a plus 4 over 6. And then I was doing the long side in the blue here to the short side to the 6 here. Okay, all right, 1 more, and then you're done. Okay, so y over 2, hypotenuse over short side, y over 2 is equal to, this is my short side. So which one am I using? Y over 2, 7, oh, this whole one. Yep, 7. Hypotenuse over short side. This looks like the long side to me. This goes with this, and this goes with, this is the hypotenuse, and this is the hypotenuse. So y over 5 is equal to 2 over, nope, I got it backwards here. So this is y, this is my hypotenuse of that triangle, and my whole triangle, which is 7. So it's y over 7. Oh, I actually probably did have it right then. Y over 7 is equal to so this was 7 for the hypotenuse. Oh, it's going to be another one of those. Y over 2. Y. I don't know why all of a sudden I'm stuck on this. 7/5. I am having a brain fart of brain fart. I probably spent like 3 minutes on just having a brain fart. All right, so y/2. That's for the small triangle. 7 for the long triangle. 7/y. Yeah, it is one of those. Okay, so which is different than when I originally did it, so that's why I'm confused. So take the square root of 14, and y is going to equal 3.74. Okay. Originally, I had it set up differently, and that's why I think I got confused on it. So when I was actually doing it and talking it through, it was like, wait a second, something's not right here. So anyway, well, I didn't even know you couldn't see that part. But if you have any questions, let me know. If I did this wrong still, let me know, because, I am human. I can make mistakes, especially when I'm sitting in an office all day by myself. It's kind of crazy. Okay, miss ya. Love ya. Talk to you later.